Okay, welcome everyone. I want to tell you a story about my attempts, mostly successful, my attempts to train my dog with Micropython. He is the hero of today's presentation, my dog. And I'm Łukasz Mach, also friends call me Macho. I work as a software engineer, a Python programmer in Allegro, and if you find an open position in our company, I strongly encourage you to join us because you will find a lot of interesting people doing a lot of interesting stuff, either in doing microservices at scale or doing hobby projects after hours. So, as every dog owner, I have a problem that I need to train my dog. And training the dog, the classic way of training dog looks like that I need to say a command, then to measure the execution, then announce the reward and treat him, give him a reward to make a feedback of his correct behavior. And you need to repeat it enormous number of times. It's easy to find kind of algorithm here. It's very tempting to make it automatic a bit. But how? In some PyCon-PL, I found this small yet powerful device which has excellent capabilities, quite large storage for this size of device, has Wi-Fi and Bluetooth, and has very low power consumption. More, it has very smooth learning curve, so you can just make an experiment with that by connecting USB cable and enter Python's REPL and try how does it work. So let's use ESP32 and Micropython to harness my dog. I had a great vision of a device which was supposed to work in such a way that it would determine position, it would say the command, determine position of the dog's body to measure its progress. If progress is bigger than before, then announce the treat and give the treat and repeat it many times. In other words, I was dreaming about a machine which teaches my dog of various tricks while I'm at work. I go to work, I launch sit module. When I'm back, my dog knows how to sit. So how can I achieve such goal? I would need to measure position of the dog by distributing mesh of chips in my house and attaching one to its dog's collar, and by doing some kind of heat map, and by analysis of camera recording. Then I would need to dispense a food to him as a reward and do some kind of programming, some infrastructure. It would compose a machine to teach dog of tricks. So I decided to start from the easiest part, low-hanging fruit, which is the dispenser. I remind you that I thought that I will just buy it. It will be ready-to-use module, and I will just get to its API to release a portion of the food. And lesson learned number one, don't count on ready-mades, because if you are sure that you have some ready-to-use module, you will need to do it yourself. Because the closest to my desired device is a grain auger, but only if one of rewards is in kilograms, not grams. Or a chain feeder for pigs, however, not this size of animal and definitely over the budget. So my first attempt was a carton box with hinged lid and mechanism which tilted that lid for a while. One of first tries, it turned out that there is lack of precision. The speed of measurements is too large. Sometimes it gives no kibble, and sometimes the lid gets stuck in the open position, and the contents of the container dumps out. So next way, taking advantage of the fact that pellets are rough, so when poured from the kind of funnel, they will stick one to another, and in the result, they will block the flow. When you stir them, they will unblock for a while, and after a while, they will block again. Next attempt, it looks quite awful, but is functional. Way more precise than model with tilted lid. However, my desire of precision was unsatiated. My goal was to dispense precise enough and to be able to release one pellet per reward. I thought that it's a matter of setting the proper rotation angle, and in other words, I wanted to make mincing machine, but with low internal friction, so the simple modeling servo can rotate it lightly. Then I was convinced by evangelists of 3D printing to buy this marvelous device, and I was hoping that I will be able to create my device with higher precision and way faster. It's not entirely true, because rapid prototyping by 3D printing is not really rapid, and to use this precious device, you need to explore the ocean of knowledge about mechanics, about adjusting printing parameters. Only after a big while, your printouts start to look like something similar to what you expected. So if you have any manual skills, I encourage you to try your traditional methods, do something from carton, wood, wire, sheet metal. It's very likely that you will save a lot of time. But I didn't know that yet, so I created many prototypes of mincing machine type, and everyone ended like that something jumped inside the body of the device, and either some element went to pieces, or the engine has burnt out. Eventually, it looked like that. Note that it's very similar to the prototype made earlier, that one from a plastic bottle. Maybe this one looks a bit better. So, if I have spent so much time on dispenser, which I thought that it will be ready to use, so how much time will I spend on difficult issues? I needed to think what is possible and what is not, and if dispenser jumped from trivial to difficult, then determining location and position has been moved to maybe later category. So from as only possible means was dispenser and its logic. And how that dispenser works. It has ESP32 circuit, flashed with Micropython with HTTP server. It runs servo motor, and servo steers food in the container, and it has two power banks, which powers circuit and servo motor. So if is my only means to play, so what problems can I solve? For the starter, I have decided to solve more prosaic problem, how to convince my dog to be less annoying when guests visit me. Because when we are dining, dog wants to participate in the meal, and when I say to him leave, and he eventually leaves, to reinforce this correct behavior, I need to get up from the table, give him food, and it's not something I would like to do when guests visit me, because I want to focus on my guests, not on my dog. So I was thinking, what if I can do it in such way that the dispenser serve HTML with buttons, and if I press the button, the endpoint is hit on the dispenser, and the food is released. So programmer's method to deal with annoying dog is that when he enters the room, I say leave, he leaves, and then I get my phone, click the button, the food is released, and guests barely notice that I was focused on my dog, not on them. Another problem is separation anxiety. Separation anxiety is something which may make your coach to explode. Because dog thinks that when he is alone at home, dog thinks that he's alone forever. He is very sad, and tearing something to pieces, let's calm him down. It's very hard to fight separation anxiety, which was also an even bigger problem after pandemics, because dogs were used to be with their humans at home, and when we returned to offices, they started to freak out. If you want to train your dog to stay at home with calm, it's hard to train him, because it's hard to reward dog for being calm when you are away, because you are away. It's hard to even determine that he's calm because you are away. So you need to do some weird things, and it's just complicated and not very effective. So I was thinking, if I can see and watch what is inside my home. So there is a web RTC server streaming video and audio to my phone. And if I have buttons, then when I see that he stops whining, he stopped barking, I can click the button, and the request to release the food will be sent to the dispenser. Fun fact, I thought that streaming sound and video will be just ready brick to use from Docker, but it turned out that I had to compose this solution myself, because everyone found on Stack Overflow or other services was slightly different. So it looks superb. On the left side of the screen, you can see a camera from my house. On the right screen, it's what I see in the same time on my phone. You can notice slight delay, but it shouldn't be a problem. I thought that it shouldn't be a problem, but what a surprise, it didn't work. Instead of being calm, he started to be more and more agitated, and situation started to escalate. So when I analyzed the fact, it turned out that I was not aware of the fact that this delay is so big game changer. Because when I see that he stopped whining, so I want to reinforce this behavior, I click the button, and right before, sometimes, right before the food flows from the dispenser, he started barking again, because he couldn't resist to express his anxiety. And right after he started barking, he got the food. So what he thought, okay, barking is that thing which I should do, and as I said, the situation started to escalate, and I had to admit that this is not a good way. I need to work more on it. But what if I suppress the delay and the decision will be made locally? So there is a Python process which listens to microphone, and he waits until there is a quiet for, let's say, 3 seconds. And if it's true, then the request is sent to the dispenser, and dog is rewarded for being quiet. And this worked. So it works like that if there is silence for 2 seconds, nothing happens. If there is silence for 3 seconds, the food is dispensed. Then, if there is too short silence, nothing happens. And if there is even longer silence, food is dispensed, and the required silence grows and exponentially. And in my case, it ended near 20 minutes. So in this solution, this and this behavior was rewarded. It looks like that. What is funny, that it's very dumb solution. So it doesn't distinguish whining of dog and cry of children on the street. So I had to use it only at night, but I'm sure it could be improved. Another thing which I wanted to solve is boredom of dog. Untreated boredom ends like untreated separation anxiety, so some coach can explode because dog, if he's bored, he needs to calm himself down, and the easiest way to calm himself is to tear something. There are plenty of ways to play with boredom of the dog. There are puzzles, riddles, mazes, all toys which you can stuff with food, and dog need to make some effort, preferably mental effort, to access the tasty content. In other ways, there is no free meal. He should earn his food. So I thought I will do something like that. So I tried to create a button connected with ESP32, flashed with Micropython, connected to power bank, and when button is pressed, then the request is sent to the dispenser. And first models made from paper and plastic. Dog refused to press the button. He started to turn it over. So he started to use it definitely against the design. And lesson learned number 3, hardware is important even for a software engineer. Because as you can see, poorly designed case of the device make dog to use it way differently than planned. I have spent some time to prepare button which is a bit harder to turn over, which involved spending days on watching how slow 3D printing is when the printout is large. And eventually, the button worked like a charm. As you can see, it's a very exhausting task for a dog. Each time is a lot of considering, what should I do with this device? If I press it, will I get the food? Now he gets the food. Then will be more considering, if I do it again, will it repeat, or maybe it was something else. At the end of this trial session, he missed the button once, and he was so tired that he just went to sleep. After analyzing the logs with this sophisticated log scrapper, I find out that he has to press the button about 60 times for getting the day's portion of the food. And taking into account that current distance of dispenser and button is 8 meters, then daily distance is half a kilometer. So, and he spends 2 hours, so it's quite significant addition to his daily activity. So, summary, dog's entertainment and training system is dispenser, button, remote control with preview, which needs more work, silence detector to fight separation anxiety, and everything connected to Wi-Fi to home router. And at the end of this talk, I wanted to tell about challenges, obstacles, and interesting thoughts. So first is logging. Logging on device which has only 1 megabyte. It's not easy. You cannot just log it to disk because it will be soon, the free disk space will be exhausted. So one would say you can log it through to remote logger, but you won't know what happened before Wi-Fi, before connected to Wi-Fi. So it's quite good solution is to store events on disk and then to send it to rsyslog. So first store record on the disk, then try to connect to a remote logger if it succeeds, then flash that file, make it empty, and each subsequent record gets to remote logger via UDP. Alternatively, you can connect Raspberry Pi and connect it by USB cable to the device and watch on the serial device using Minicom or screen. Another thing is remote changes in the code. So you need to upload new version, you need to modify config, sometimes few times in every few minutes or every minute. It's not convenient to use it by USB, which is standard method. You use a package from PyPy, but device is mounted somewhere. The wire is not always long enough. We are not always close enough to the device. So the alternative solution is use WebREPL. It's REPL over WebSockets. It's built into Micropython, and you can use it, access to it by using Web GUI or transfer files through the WebSocket using a package from pip. It's very slow, but for small files like configuration, it should be enough. Or you can use Immortal Raspberry Pi, connect it by USB and use it as a jumping station, transfer files to Raspberry Pi and connect and transfer files from Raspberry Pi to the device using USB method. Another thing is powering the device. I wanted to power it from one source, make some voltage stabilization, but problem is then when engine started, the voltage dropped on the device, everything restarted and was very unstable. So I have spent a lot of time on trying to improve this stabilizer, but then I realized that power banks are cheap and I don't need to spend so much time on making things ideal. I can just connect two power banks separately and problem is solved. So lesson learned number 4, don't optimize, scale it up. It may be good enough, which is the truth we should know from the beginning of our lives, but we forget it too often. And the story with powering is continued, because it turned out that if I power it by power bank has such capability that where the power consumption is very little, then it turned off because it thinks that nothing is connected. So you find better power bank such that won't turn off. There are no such power banks on the market. Everyone turns off, for example, at 65 milliamperes or 115 milliamperes, or there are rare cases where when power banks requires whole 1 ampere to be connected, to not turn off. It's not specified anywhere. You need to buy and try, and it was a bit annoying. So when I added additional power drainage, like additional 35 milliamperes, then in summary it was 70 milliamperes, and it was over the threshold. So one would say problem solved, but I thought it's wasting of energy. We need to waste half of the power only to avoid turning off a power bank. I need to charge it more frequently. So if I draw current in narrow peaks, it should be enough. Internet is full of examples how to do it. So looks like trivial to do. I found the most promising schema on Stack Overflow based on popular chips which pass the current through resistors with low resistance every short time, and it worked like a charm on a breadboard, but I was unable to solder it. I don't know why. Maybe I'm just too clumsy to do that. And I have spent again too much time on making things perfect, but then I realized that I don't need to do that because power banks are cheap. The 10 ampere hours power bank is quite popular these days. And simple math shows that it would stay for almost 5 days. So charging, the math shows me that charging every 5 days, it's something I can afford. Instead of doing fancy, complicated solution which I was not able to deliver in reasonable time, I should use simple solution and do vertical scaling. In this case, use bigger power bank. So lesson learned number 4, again, don't optimize, scale it up, it should be good enough. So now I'm really finishing. The lesson learned in this project is don't count on ready-mades if you are sure that a component will be ready to use. Is that one you will need to make yourself? Rapid prototyping by 3D printing is not really rapid. Hardware is really important because if you are excited that you will do super programmistic solution, you may stuck in a hardware problem and never get close to merit of it. And don't forget about scaling, especially at the beginning of the project. And portable Raspberry Pi is good for everything. You can see, you can get code of this solution if you want to clone it in your home. And if you have any questions, I'm all ears.